All right, everybody shut up. Welcome back. What do we think of that? That artwork.
Oh, that's pretty cool.
Does it look pretty cool?
I think it looks pretty cool.
So this is an artist, his name's Create, K-R-E, then the number 8. What we're going to be doing is we're going to be turning now that we're in the middle of the renovation of the department, we're going to be turning the hallway into kind of like an art gallery type thing. So this guy's hard to collect. So I just bought several of these myself from Park West. So I'm going to put my own stuff up in the hallways, but then we got some other paintings coming that are some other cool things. We got one that has like a John the Baptist. It's the lady holding his beheaded head in a platter. That'd be pretty solid. So it's going to be like edgy artwork. So you have that to look forward to here in the coming weeks as those things start pushing through. Yeah, I just got back from a 3-week cruise. I was on a famous ship that all of you have seen. It's called the Diamond Princess. How many of you recognize the name of the ship? It's the one you saw stranded off of Japan at the beginning of COVID for a month and a half. So I was on that. I was on that ship. It's over here doing cruises out to Hawaii because Japan's still closed, but it's on its way back over there now. But I was just that ship. Okie dokie. So this is 250, right? That's the class we're okay. So the second coding class. All right. I think I told you at the end of class last semester, I'm going to try to get us moving into Unity a little quicker. This term that I usually do 8 weeks of Java, followed by and then the second 8 weeks we move over to the Unity game engine where we get some more visual stuff. And that uses C# as the language. But again, I teach from the perspective the programming language doesn't matter. Programming is programming. So what I'm going to do here is in our first, let's call it two weeks or so, 2 to 3 weeks, we're going to kind of crash course Java, and we're going to be converting our dungeon crawler into Java. So we're going to be learning Java in terms of the thing we were working on at the end of last semester. If some of you are new in this class who didn't have the 200 class last semester, it's not going to be a problem because we're going to be starting that project from scratch. We'll just be modeling it after what we had done before. So we'll learn about object-oriented Java and some of the little nuances that are different in Java versus C++, which we looked at last semester. And then what we'll do is we'll roll into Unity. We'll do kind of a crash course in Unity, and then we're going to develop our dungeon in Unity. So you'll actually have like a 3D dungeon crawler where you'll be able to control your guy rolling into rooms and stuff like that. And then for those of you who are interested, outside of class, I can get you connected with some of the VR headsets, and you can actually convert your Unity game into a VR game if you want. It's not very difficult. All you do is replace the Unity camera with the Steam VR camera, which controls your hand tracking and stuff like that. You might have to screw around with perspective a little bit because it's possible you'll either be a giant in a small world or an ant in a giant world, depending on the initial scale. But all that stuff is easily fixable. So basically, you can go from a normal 3D game to a VR game in in 5 minutes. You won't have all the controls because with VR, you'll be able to hook up your controllers. You'll be able to reach out and pick stuff up, but you have to program that. But you'll understand how that stuff works. It's not actually very difficult. So hopefully we'll be into Unity fully by week 4. So about a month earlier than we typically are. Does that sound reasonable to everybody? We're still going to be doing the same programming stuff. We'll just be hitting C# a little bit quicker, but C# and Java are basically twins. So there won't be major jumps in language stuff, but you'll get more of that visual feedback and being able to get some more designy with your stuff quicker. All right. Same thing as last semester for assessments. So I'll put your Bible homework up this week. It's due by the end of final exam week. So just like last semester, there'll be 2 assignments, similar size, probably read a book from the Bible, write a 1 to 2 page response thingy majiggy on it. Ultimately, what am I doing? I'm forcing you to read the Bible. You know, if you do it, you're going to get full credit on it as long as you don't turn it into a joke paper or something like that. You know, if you're not a Christian, that's not the end of the world. You're at least making you read the book. So just academically read the book and then write your response to it. Won't be the end of the world. Assignments, again, 50% of your grade, just like last semester. I give quite a few homework assignments, but I grade them very easily. Assignments are your practice for the big game. So this is like you going to a basketball practice or something like that. And, you know, that's your opportunity to make mistakes, but I expect that you're going to put the time in, the hours in to really drill. A lot of you came up after the midterm last semester or even after the course last semester, like, oh, what can I do over break to, you know, practice so I don't lose track or I can strengthen some of my skills for the next semester. It's time. You know, you got to be working on these little puzzle type assignments like this, and just put in the reps so that you make all the mistakes early so that you're ready for the exams. And also you now open up new doors for working on more complex things. Just like last semester, 2 exams, 1 midterm, 1 final. Midterm will be around week 8. Final will be at the end. My policy is if you do better on the final exam than you did on the midterm, I'll replace whatever grade you got on the midterm exam with what you got on the final exam. So again, you have every opportunity to finally get successful in the class all the way to the end. Questions about any of that? Okie dokie. Same thing as last semester with all the programming assignments. Turn in this self-assessment template thingy. It'll also be in Blackboard. You know, I want something like this. Some of you have your own format for it or whatever. Effectively, what I want you to do is tell me the story of how the assignment went for you. Because sometimes with programming, especially now as we're getting into probably a little bit bigger projects, you might spend 5-6 hours on an assignment and have very little to show for it. Fill in those gaps for me so I can find points for you. Okay. I'm going to find out on the midterm or the final if you're learning stuff. But along those same lines, I encourage you to find a kind of a study group, maybe to get together and work on the assignments with. You know, I'm not going to sit there on homework assignments looking for people who are copying off each other. I'll find out on the exams whether you've learned anything. So I encourage the maybe some of the more experienced students to run study groups and take some of the less experienced or the struggling students under their wings and let them kind of come into that group and learn from you. Some of you might learn better from a peer rather than, you know, me doing something, or when I have 15 minutes left in class and I need to get more stuff done quickly and I start coding a little faster. So then, you know, things start zipping by. So, you know, this is all a learning experience for all of us. So, you know, take advantage of that. So I'm not looking for cheaters on homework assignments. Not all your teachers will be that way. So make sure you don't, you know, take that policy outside of this class. But, you know, I want you to learn as much as you can learn in the class, however you're going to learn in the class. The only time I want you to be completely self-sufficient is on the exams. All right, no teamwork on the exams. I want to know what you've learned. But again, I give you the get out of jail free card on the exam too, which I think is pretty fair, right? You know, so you know, I want you to ultimately be prepared for those exams to show me how well you've mastered the material, because that's the only thing I'm giving grades for, is whether or not you've mastered the material or not. All right. So yeah, something along the lines of the self-assessment. If you have a different format you want to write it in, that's fine. I don't care. Just tell me about how things went, what works, what doesn't work. You know, I spent 7 hours in this and I hate you, you know, something like that. And some of those can get pretty funny. That's me. There's my email address. That's my cell phone number. I strongly encourage you not to call it. I only pick up for my wife or my mom. but text me. Texting is great. Just tell me who you are and what class you're in, because I teach more than just this class. And I'm happy to answer questions. We also have our Slack channel. So most of you should already be on Slack, but if you are new this semester, go to cuwcs.slack.com and you can sign in. Well, you'll create an account with your cuw.edu email. And then you can join Slack. And once you are in there, there is a 250 class. You might have to go under channels and hit this little the 3 dots and go browse channels to find it. But there's a 250 channel, so get into that guy and I'll go ahead and star that channel so it'll be up in my top collection. All right, so this is also a good place to ask questions. I'll post code on here, I'll post announcements on here, so be checking Slack on a daily basis. You know, just in case there's a change in class, class is canceled or something like that. I don't anticipate that happening this semester because my wife's chemotherapy is on Thursdays and this class meets Monday, Wednesday, Friday. So we should be in better shape this semester than early on last semester. All right. So definitely get on Slack, set up notifications. We also post things about internships and stuff like that on Slack. So really make an effort to check it daily, because there is stuff in there that if you don't see and you miss, that'll be a problem. We will have some required tech talks this semester again. I think we're going to end up having either 3 or 4. I'm hopefully going to have all the dates finalized this week, so I'll get the dates up so you can, if you have to get time off of work or something like that, it'll be in the evenings from 6 to 8 p.m. or so. Down in the business building is typically where we have it. Sometimes we'll have it in here, where we bring in speakers. We have at least I think one of our tech talks this semester is 2 former students who are working for SkyGen, who spoke last semester, coming back and talking about what they do and the internship program at SkyGen, as well as what working as a full-time person there is like, yada, yada, yada. So these are important things. I do require them. There is an alternate assignment if you aren't able to make it. We will also have at least 1, if not 2, hackathons this semester. I am deciding whether I'm going to require those or not. Hackathons are a really, really, really good experience. You learn a lot in a very compressed period of time. And even though you are, in the less experienced group of computer science students, there's still something to learn from the more experienced students. And where they divide the teams up based on, we kind of get a couple of junior seniors and a couple of freshmen, sophomore in the team. So hopefully, even if you're shoulder surfing, you learn something from it. Typically, hackathons are like 24-hour programming events. We try to make ours like 8-hour dealies. So in any case, keep an eye out for announcements for those. But you'll get emails about that stuff too, but we put everything up on Slack. So definitely get on Slack and set up notifications. It's on all your, Mac, PC, iPhone, Android. It's on all the different dealies. Okay, questions about any of that stuff? Okie dokie. All right, so these are just a couple of repeat statements. As promised from last semester, I started a fresh set of slides. I had like 2 death threats last semester about the slides. I had to check my tire pressure every single time I got in the car, make sure I didn't get them slashed. All right. So again, I want to remind you, and this is something you're going to see pretty quickly in this class, is computer programming is the skill set that we're learning in here. It's not computer science, so don't confuse computer science and computer programming. Okay, if you're a computer programmer, that does not make you a computer scientist. Computer programming is the skill, like kind of the hammer that the computer scientist wields to perform a lot of our science. All right. Some of you might go into careers where you have more or less programming as part of your daily job. Not every job inside of computer science requires you to write code all day long. Some of them might even have you writing code relatively infrequently, but there will be times where your computer programming skill set will come to bear. And in many cases, those jobs where it is not commonly used, those are actually going to be the harder times, the harder programs you're going to have to write, because you'll be working with kind of automating processes on systems that aren't necessarily overly conducive with that. Maybe you'll have two different, server type systems, and you need to get these two guys talking to each other, or two different software packages, and you need to get them talking to each other, and they don't know about each other. And you have to find out, how does this dude communicate, and how does this dude communicate, and how and where do I write my program to talk between these two things? And it's not going to be set up as a real friendly computer programming environment, because it wasn't meant to have that communication. Otherwise, they would have built that integration into it. All right. As opposed to if you are a day-to-day computer programmer, and you'll hear this from the SkyGen former students who are coming in here. One of them's Noah Kurz, who was one of our strong students 2 years ago. These guys, they write software day in, day out. So they have very mature tools that they work with on a daily basis for writing code, much more mature than the online GDB that we use in here for convenience purposes, so that I don't have to manage a whole bunch of different installs of IDEs. If you want to use a Java IDE like Eclipse or NetBeans or something like that, that's fine. I don't care. Just I don't want to have to help you get it set up and things like that. So I'll continue to use the website thing. Once we go to Unity, we only have one choice. We're going to be using Unity, so then I'll have to support that to some level. But yeah, so when you're in a full-time, and I'll come there in a second. So when you're in a full-time software engineering type job, you'll actually find that a lot of the programming is actually more convenient, because you're working in a world that is leaning towards code all day long, and you have nice friendly tools where connecting to a database is a couple of pushes of buttons and things like that. So, but programming is the weapon that we wield to perform a lot of our science. It's not computer science itself. But
you consider ChatGPT a writing tool?
that is a super interesting question. How many of you have heard of ChatGPT? Let's just open it up here real quick. It is stupid. It is. Oh, it's better than that. I went in last semester. So this is an artificial intelligence based project. Let's see, here's the try. Oh, this is like oh, I see. Well, while that's cooking, just to give you an idea here, I'm going to go ahead and I'm just going to open up some exam questions from one of our exams. Oh, here I can get it off of an old 250 exam. Write a class method named string to char array that takes a string as a parameter and returns a char array containing the contents of that string. I'm going to paste that in here, and it's going to write that code. It is ridiculous. And I have a couple of students working on some stuff with this where we've put significantly more complex things in than that, and it's accurately written it. A buddy of mine who also works at SkyGen, he actually was Bobby Eberhardt. Was he here for last year's SkyGen talk? Kind of a 30-something-year-old, pretty big dude. Well, he's a network engineer at SkyGen, a good friend of mine. And so he would have that type of job where he programs sometimes, but programming is not a core part of his job. So when he has to do programming stuff, it can sometimes be kind of a headache. He's been using ChatGPT, and it's been writing working connectivity code. I mean, it's like stupid. He texted me a couple weeks ago saying that it's effectively doing Bobby makes a couple $100,000 a year. So I mean, this is not an entry-level position, and it's doing like half his job for him. Yeah.
Oh, no, I can just figure out.
Sure. Get notified when we're back. It's like, well, and actually, so let's just keep going with that a little bit. So keep in mind that, so this is something that we formed a panel here at the university. So I'm on the committee for this. So the provost's office has reached out because this is a known tool. So your faculty members know about this. So they're going to be looking for ways of telling whether what you submit came from this. So don't use this. Now, having said that, certainly from a programming thing, I would say if you're working with your group of people on your homework assignments and you're just all stuck, this can be a good learning tool. If you can type something into it, get the code, and then work through it and say, okay, what were we missing? Where were we getting stuck? And what was the solution to jump past it? Because it's shockingly good. Okay. But there's lots of papers out about this right now. But so there's some, there was this scientist lady who wrote this article, because you can like say, put in there, like, you know, write a 3-page paper on yada, yada, yada subject, and it'll do it. And it sounds like a person. When the provost originally reached out to me asking me about this, my opinion on this, what I did is part of my response to her, I copied her question she wrote to me from the email. I pasted it in here. I copied the response, and it sounded like a completely legitimate response to her question. And I told her, by the way, I didn't write that. So that just gives you an idea of kind of what you're dealing with here. But I'll tell you what, there are, and I'm not going to tell you what they are, but there are some telltale things you can use. There's some tools that are coming out specifically to detect ChatGPT. Yeah. To be honest, from a computer science point of view, I think it might be harder for us to detect it. Because code is kind of code, right? Where we'll really see it is when 4 of you all turn in the same answer with the same variable names and everything like that. And your source for it was all ChatGPT. From my perspective, I might not know you got it from ChatGPT, but I know that you did it together. And that doesn't just come in the form of, oh, your variables match. Because sometimes, you know, you have small enough little programs that you created a string, you named it S. That's a perfectly reasonable name for a string. Where it really comes down into where there's very kind of unique, weird variable names. And those are, you know, pretty obvious. All right, well, we'll let this cook. We'll bounce back to it a couple times. How does it work when we say notify us? Oh, I have to wait for the email to come in. This might actually work because I have my watch on.
In the middle of the night, the email comes through.
Yeah, but it's fine. Trust me, I'm gonna paste that code in there, and it's gonna give us working code. Yeah, it's really ridiculous. Let's see, online GD. All right. But in any case, I do encourage you to play around with that tool and just kind of see what it can do, because there are educational reasons where it can be used to help you. You know, anything that you can do to help you learn, I think teachers would be an advocate of, as long as you're not turning around and submitting that as your work. You know, if you want to use it to give you a baseline and say, okay, now I have some information, maybe it's even a research paper, and you have 5 or 6 different sources that you've, you know, gone and worked from, and then you have kind of a pre-written response. and you use all those things together to formulate your own ideas, your own words, and you write that. That's reasonable. You're learning from those different sources. One thing I pointed out, though, we had that scientist lady, and what she did is she tried to give it like a question that was with like made up sciencey terms. And it wrote such a good response that she questioned her own aptitude and was like, wait a minute, I thought that was made up. Was that actually a real disease or something like that? So she had to go and research her own words to find out that what it had replied with was BS. That's how convincing the response was. It wrote like a 4-page paper on something made up and made it sound real. Still fun.
It's kind of interesting. You all cited sources. They'll give you URLs that don't work, but are like predicted to places that might have posted things about the topic.
Yeah.
Just like
Yeah. It's shockingly impressive and really an example of where artificial intelligence is. Today we're right on the cusp of something pretty ridiculous. But it is what it is. What's this?
How many jobs will become so simple because of it?
Well, or how many, one concern that's always been there with computers and robots and things like that is how many jobs will be replaced by machines? If the job can be done by a machine, it should probably be replaced. But that will then open new jobs that are more advanced things that can only be done by humans. Okay, that doesn't mean they're necessarily harder. They just require our human approach to the problem solving. Frankly, if a computer can do the job, it's probably going to do a better job than a human being anyways, because it'll be less error prone. It won't get tired. It won't have to work 8-hour shifts with a lunch break, and 2 smoke breaks or something like that built into it. There's nothing wrong with that. It's what's the right tool for the job. And that was even on one of my slides here, I think. Should always strive to solve problems with the right tool for the job. Sometimes it's one language versus another programming language because a certain language lends itself to maybe a collection of tools that let you write network type programs easily or something like that. Or for instance, you're writing web-based stuff. PHP has a lot of built-in web-based kind of stuff built into it. So that would be a kind of a convenient language to write, a website, a dynamic website with. Well, we take this outside of just programming. If a robot or a computer is the right solution for the job and it's going to make less mistakes than a human being, who wouldn't rather make an order at McDonald's using an artificial intelligence? ChatGPT is going to get your order way more right. You're going to get to the point where you'll have a fully automated McDonald's. There won't be humans in there. It's going to be like basically the size of like a big refrigerator. So it's going to have everything inside to do all the cooking and stuff like that. And just going to vend you your Big Mac with the correct things removed from it or added to it or whatever. You won't order a Diet Coke and get a strawberry milkshake.
An upgrade.
All right. So let's start looking at Java here. Let's first, this is just a reminder slide, right? I'm not going to beat a dead horse here, but my basis for teaching programming, how do human beings solve problems? Memory, asking questions, repetition. 100% of every single programming language has facilities for mimicking these 3 things. Typically, memory is done through variables. Questions is done through conditionals, if statements. Repeating tasks is done through loops, functions, procedures, methods, whatever you want to call them. All right. Every single programming language has facilities for all 3 of these things. So if we can quickly learn how to define variables, ask questions, and write loops in a brand new language, we can immediately start harnessing that language. Okay? The starting point for any programming language, when you first start to learn it, is going to be writing that working Hello World program. And it has nothing to do with Hello World. It has everything to do with what is the kind of the template for a running program in that language with the correct voids in this place and statics in this place and the correct parameters being passed into whatever to get you a program that functions. When you go to run it, it just spits Hello World out to the screen, just a simple working program. And you can use that as your baseline to build other programs off of. Make sense? So that's what we're going to look at first. But as a starting point, let's just give us a quick slide on C++ versus Java. So C++ versus Java. First thing, you can pretty much replace the word Java here with C# as well. So I've mentioned that we're going to be looking at C# here pretty quickly with Unity. Java, C#, they're the same thing. I was at the ACM convention in, this must have been like in 2000. So maybe 23 years ago, I guess. He was in at the University of Illinois in Champaign-Urbana. And this was right after, so Java had already been out for maybe 3-4 years, 5 years. And Microsoft had already stolen Java and come out with their own product with Visual Studio called J#, or I think it was J++ initially, which was Java syntax, but using Microsoft, whatever. Sun Microsystems, who were the makers of Java. So here we'll put down Sun Microsystems made Java. That company was ultimately purchased by Oracle. Everybody in here heard of Oracle? What does Oracle do? We got basketball stadiums named after Oracle, but it's one of those companies that most people, even computer science folks, don't know what product they make. Besides Java, I guess. Anybody know what product Oracle makes? Literally 0 people in the room. Oh, so you know, but they make well, everybody is. They make an enterprise database. Yeah, but I mean, effectively, they are a database management system. They would be a competitor to like Microsoft SQL Server or IBM DB2. These are high-end enterprise databases. I believe Amazon uses Oracle as their, or at least at some point in time they did. It's possible they went over to their own crap or something, but the junior version, like programmers like us, we typically would start off using something like MySQL or SQLite or PostgreSQL. These are kind of lightweight database management tools for a normal number of simultaneous users. And by normal, it could be thousands. Whereas Amazon's dealing with more than just thousands of simultaneous users. So they need more of an enterprise type of system. But that's what Oracle does. They make a database. And it's thought to be one of the fastest, yada, yada, yada. Well, anyway, so I was at the ACM conference after Microsoft had stolen Java, which all these big companies do that same crap, right? They find something they want, they take it. If they get sued, they usually settle outside of court and they end up getting it for less than it probably would have taken them to make it and much quicker. Just that's how business is done at that level. So, you know, I'm an advocate of not necessarily demonizing Microsoft because any of the other big companies will do the same crap. It's not the way things should work, but this isn't a Microsoft problem. This is you know, when you have zillions of dollars, it's just cheaper and faster to just steal it and pay your penalty. So in any case, the difference is that Sun Microsystems was not like some, you know, kid writing software in his basement. You know, they were a big company. They made servers. They had Sun stations. They had their own hardware. So a lot of like big companies use Sun servers for like their Unix servers, email servers, web servers, things like that. So anyways, Sun fought back. big lawsuit. Sun won. Microsoft could no longer use Java syntax, yada yada yada. So Microsoft went and created their own brand new, built from the ground up language called C#. So I was at the unveiling of the C# languages before it went public. It was the beta version of C#. I think it was 2000. It might have been 1999, somewhere in that little zone. But in any case, everybody goes, when you go to these conferences, you always go to the Microsoft talks because they give away the best free stuff. So everybody else, they give away little bouncy balls and stuff like that, or like stocking caps. Microsoft was giving away box sets of Visual Studio 6.0, which was like a $600 software that obviously all of us had already pirated. Don't do that. So we sold it on eBay. It was the early days of eBay too. So we probably got $400 for it. You just had your ethics course. Don't do that. What I just described, don't do that. But in any case, we went there and this guy in the front of the room was basically describing Java, but in the context of, here's this brand new language built from the ground up, blah, blah, blah. No problem. It is a slightly different syntax. The similarities being equivalent to like the similarities from C++, right? So we can say here that Java is based on C++. So you're going to see a lot of syntax that completely matches. We could take a high percentage of our code we wrote last semester, paste it into a Java program, and really only have to make changes to like small little parts of it, not really the logical pieces to make it work. And you'll see that in the Hello World program here in a minute. So Java is based on C++, just like all of our other languages are. If you remember last semester, we had kind of our history tree. We had C, then C++, and we had Java and C# that came off of that. We had Objective-C kind of off of the C++. Well, you had Java, then you had C# a little bit lower down, kind of branching off. Somewhere over here, you had Swift from Apple. But in any case, all these languages have the same history, the same core history. So Java is based on C++. Now, I will say that, as much as we can sit here and say, well, Microsoft just duplicated C# or duplicated Java with C#, they did improve upon it. So Java is considered platform independent. Anybody know what that means? When I say that a language is platform independent, go ahead. Yep. So last semester when we talked about C++, we talked about that C++ is a compiled language, right? And when you compile a program, you're targeting a couple. So what does a compiler do? Remind me. Compiler converts between what and what?
You write to the code that you understand, which is a bunch of.
Yeah, so a high level language like C++ goes through a compiler and turns into a low level language like assembly. And assembly, that low level language, is native to a processor and is also married to an operating system. Remember, we looked at Hello World and Linux assembly last year, and we had things where we were moving memory things into hardware registers, which is dealing with the actual hardware of your processor. But we were also seeing that it was setting things up so that the operating system can find out which of the system calls you wanted to use in order for it to leverage, right? So it was still using the operating system to accomplish this, which means that the assembly code for Hello World on Linux running an Intel processor will be different than the assembly code for Hello World on Windows, also running the same Intel processor. So it's, even though they're the same physical processors, because they're different operating systems, the assembly code will be different because it does leverage the operating system and the power tools built into the operating system for accomplishing these tasks. So compiling has to take two things into consideration. What hardware am I turning this into? That dictates which assembly language am I using? And then what operating system do you intend to run this on? So I can make sure I write the assembly code in terms of that operating system and the correct system calls. That makes some sense? So what does that mean? That means if I have a Hello World program that I've compiled for Intel Linux, and now I have an executable called hello.exe or whatever, I can't just take that and drop it onto a Windows machine and double click it and have it run Hello World. It's the right hardware language, the right assembly code, but it's talking to the wrong operating system. I would have to go and recompile it. Now, chances are for a Hello World program, I wouldn't have to make any changes. I wouldn't actually have to physically change my program, Hello World. I would just have to go and recompile it for the correct operating system. Same architecture, but a different operating system. And it would give me a different output that would then run Hello World on Windows. Okay, but I still had to go back, and that's called porting. I had ported my software from Linux to Windows in that example. But you can imagine Hello World is this really tiny little program, right? So as we get to larger projects, are we out at 50 or 55? 55. Okay, we got 4 minutes. We're good. Always yell at me because sometimes I don't know if it's Tuesday, Thursday, or Monday, Wednesday, Friday. Yeah, so if I keep going, somebody tell me to shut up. And then we'll just pick up where I left off next time. All right, so in any case, that's called porting it. But as you get much bigger programs, for instance, let's say a video game or something like that, chances are you're going to have to go back and make substantial changes to the actual programming language, especially when you're dealing with 3D video libraries. Like, for instance, Windows uses something called DirectX, and everybody else uses something called OpenGL. And those are different graphic libraries. So if you write it in OpenGL, you can make it work on Windows with an OpenGL library, but you lose some of the special one-of-a-kind thing that DirectX has that integrate directly with the operating system to make DirectX better on Windows than OpenGL is on Windows. So in any case, you sometimes do have to go and change your programs when you go to recompile them if you're writing it in C++. Java, by being platform independent, means write the code once and it will run on any computer that has the Java virtual machine. So that means what they did is they wrote this program called the Java virtual machine, probably in C++, and they ported that to Windows, to Mac, to Linux, to Android, to iOS, yada, 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 all the different platforms, right? So they did make those changes. They did port it. So now you have that software, the Java virtual machine, which is effectively a software-based computer. And it's the Java virtual machine that has its own assembly language and acts as an operating system because it knows how to talk to the underlying operating system for that particular operating system the virtual machine is running on. Which means that when you compile your Java program, it knows how to speak to the Java virtual machine, regardless of which computer the Java virtual machine is running on. Make sense? So that means you only have to write your Java program once, and it will run on any computer that supports the Java virtual machine, which is all of them. Just keep it like that. But that does come with a trade-off, a little bit of performance. Because when you're running your Hello World program on Linux in Java, it's the Java virtual machine for Linux is having to translate the Java request for printing something to the screen to the Linux request for displaying something to the screen. Whereas if you're doing this on Windows, the Java virtual machine is having to translate the request to print something to the screen in Java to the Microsoft version of printing something to the screen using Microsoft system calls. So it's doing that mapping during runtime. So it's almost like Java is a compiled and an interpreted language at the same time. There's a level of interpretation that's occurring. Make sense? And what are you giving up there a little bit? Giving up a little bit of performance. But what are you gaining? You're gaining platform compatibility. That performance is something that's not really noticed for things like business applications. So you see a lot of like investment platforms that have like their full, day trading investment thing written in Java. It launches right out of the web browser. Fast enough for that. You don't see a lot of video games written in Java. All right. Questions, comments, concerns, bribes. All right, I will see everybody on Wednesday. I'll get the stuff loaded into Blackboard and get that all opened up today. My flight literally came in at 8 p.m. last night. So that isn't to say I didn't have internet for the last 3 weeks, but I just didn't do it. I just didn't do it.
It's a good.